All right, let's get right into it. Today, we're pulling back the curtain on the secret architecture that's making the smartest AI agents tick. We're going to find out what separates a basic, kind of clunky chatbot from an AI that feels like it can actually reason.
You've probably felt this, right? You talk to one AI, and it's incredible. It's dynamic, it adapts, it seems like it's actually thinking. Then you use another one, and it just feels stuck, like it's on rails, a one-way track. Well, there's a reason for that. A lot of the early AI apps were built on these really simple, rigid paths. They just followed a script, one command after another, with absolutely no way to go back, rethink, or fix a mistake.
And the solution to that rigid, one-way street problem? It all comes down to a single word: graph. But here's the twist. In the world of AI, that word means two completely different things. And understanding that difference is the key to unlocking how today's most powerful AI agents are built.
This brings us to what we can call the dual graph paradigm. It sounds fancy, but the idea is simple. It's about using two very different kinds of graphs together to create something way smarter. This is the blueprint for building AI that's not just knowledgeable, but also resilient and adaptive.
So what are these two mystery graphs? Well, on one side, you have the knowledge graph. The easiest way to think about this is as the AI's structured library, or its long-term memory. This is all about what the AI knows. And on the other side, you have LangGraph. This is totally different. This is the AI's thought process, its decision-making engine. This is all about how the AI thinks. One is data, the other is logic. Okay, let's dive into that first world, the knowledge graph. This is all about giving our AI a solid foundation of facts, grounding it in reality so that its answers are actually accurate and, trustworthy. So what in the world is a knowledge graph? Don't let the name intimidate you. It's just a way of organizing information like a giant interconnected web of facts. You have nodes, which are just things like a person, a company, a city, and then you have edges, which are the relationships between those things. So Paris is a node, and the relationship is the capital of is an edge connecting it to another node, France. Now, the really crucial part here is that this gives the AI a source of truth to rely on. And that is our #1 weapon in the fight against AI hallucinations.
But okay, so we've got this web of facts. How does that actually help an AI answer a question that's kind of tricky? Because it's not just about looking up one isolated fact. It's about seeing how all the dots connect.
And this is where the magic really happens. It's a process called multi-hop reasoning. Let's say a user asks this super specific question. A simple keyword search would totally fail here. But an AI with a knowledge graph can literally walk across the connections. It hops from the Neo4j database to the company that developed it. Then it makes another hop from that company to its CEO. And then it makes one final hop from the CEO to the university he went to. It's connecting the dots to find an answer that wasn't written down in any single place. Okay, so that's the what it knows part. Now let's shift gears to our second graph, the one that defines how it thinks. This is where a tool called LangGraph comes into play, giving our agent its actual operating instructions. So remember that one-way track we talked about? The technical term for that is acyclic, which is just a fancy way of saying there are no U-turns allowed. Once you go forward, you can't go back and try again. And that's the big limitation. LangGraph's huge innovation is that it allows for cycles. It lets the AI loop back, reconsider a step, try a different tool if the first one fails. This is an absolute game changer because that's how we think. We pause, we reflect, we correct our mistakes. This enables real iterative reasoning. If you put standard LangChain and LangGraph side by side, the difference is stark. Standard LangChain is linear and mostly stateless. It's great for simple Q&A bots and quick prototypes. But LangGraph? That's built for the complex stuff. It supports cycles, it has a memory, a persistent state, and it allows for all kinds of complex branching and looping. It's the architecture you need if you're building a truly adaptive agent that has to think on its feet.
Now we get to the really exciting part. Because the real power isn't about choosing one graph or the other, it's about what happens when you put them together. This is where you get this incredible synergy between what the AI knows and how it thinks.
Here's the core concept to hang on to. The LangGraph is the agent's brain, its central operating system that makes all the decisions. And the knowledge graph? That's just one of the many specialized tools in its toolbox. It's like a trusted library of facts that the brain can choose to consult whenever it needs to. The thinking part decides when to access the knowing part. And this is what that actually looks like in practice. A complex question comes in. The LangGraph agent doesn't just start searching blindly, no. First, it analyzes the question. Is this hard? Is it easy? Then it might break the question down into smaller, more manageable pieces. And this next part is crucial. It acts like a smart traffic cop. It says, okay, this part of the question is about relationships. Who's connected to what? That goes to the knowledge graph. Then it might say, this other part is more about meaning and context. That goes to our vector search tool. And finally, a different part of the agent's brain pulls all those answers together into one single coherent response. It's true orchestration.
But of course, with all this incredible power come new challenges. Big ones. When you start building these systems for the real world, you run headfirst into some serious issues. And security is right at the top of that list.
So here's the danger. Every time we ask a large language model to take a user's question and turn it into a database query, that LLM is basically acting like a code compiler. And that opens up a massive security hole where a bad actor could trick the LLM into compiling a query that's actually a malicious, destructive command.
And look, this isn't some theoretical threat. A real-world security vulnerability disclosure put it in no uncertain terms. Without the right protections in place, this kind of attack can lead to a full database compromise. That is about as serious as it gets. So, what do we do about it? Well, you have to build a defense in layers. First, the absolute basics, the principle of least privilege. Your AI agent should only have read-only access to your data, period. It should never, ever have the permission to change or delete anything. Second, you need safety checks that are actively looking for and blocking dangerous commands like drop or delete. And third, you have to validate the code the LLM generates before it ever gets a chance to run. You inspect it for any red flags, no exceptions.
And there's another real-world complication: choosing the right database to even build your knowledge graph on. You could go with a native graph database like Neo.j, which is phenomenal for really complex, deep relationship queries. Or you could opt for a multi-model database like DB, which lets you handle different kinds of data in one place and maybe simplify your overall setup. It's a fundamental trade-off between specialized power and operational simplicity.
So after all that, let's bring it all home. What's the big takeaway here? What does this whole dual graph idea really mean for where AI is heading?
Well, it really boils down to this simple choice. When do you use which graph? You use a knowledge graph when your main goal is to ground your AI in verifiable facts, to boost its accuracy and fight hallucinations. You use LangGraph when you need to build an agent that can handle complex, multi-step conversations and remember what's going on.
But here's the real secret, the crucial point of all this. The most advanced, most powerful AI applications don't choose one or the other. They use both. They use knowledge graphs to define what the agent knows, and they use LangGraph to define how the agent thinks. It is the fusion of knowledge and logic that creates true intelligence.
And that leaves us with one final big idea to chew on. For a long time, the race was just about stuffing AIs with more and more data. But we're shifting into a new era now, an era where we realize that the best AI isn't necessarily the one that knows the most, but the one that knows how to think. It's not just about building a bigger library, it's about building a better reasoner. And so the real question is, how is this fundamental shift going to change everything about the tools we build, the companies we create, and the world we live in tomorrow? Thanks for tuning in.